Okay, hello everyone. This class is going to be about numeric basis. So I think most of you know about how this works, but I still have to cover it because there are assignments based on this, such as, well, there used to be two assignments based on this, like Data Lab 1 and 2, but now there we are going to combine them into one assignment. So it's going to be one assignment, and it should be much easier than before, and some of the problems are going to be reduced from before, to make your life easier. What we're going to talk about is like numeric bases. So there's like base of 10, which we always use, like 0 to 9, and there's always the notation like base 2 notation, which is the binary. And I think in case you didn't know, most of the machines actually understand binary only. And we are going to see how to convert between them, and the fact that they are basically just representation of the same numbers. Okay, so yeah so if we want to actually convert a 10 notation to a, like, okay, so over here, okay, another thing I have to mention is from now on many of the classes are going to be very theoretical, so I might not be showing codes too much and mostly focus on the slides. I hope that's not much of a problem. When we are going to represent this, what we do is we start from the right side. The first one is going to be 0, then 1, then 2, then 3, then 4, and so on. So that's how we work with the base 10 notation. In case of base 2, we are kind of cheating over here. So whenever there's a 0, we just like totally ignore them. For example, over here there was a 0, so there should have been something like plus 0 into 2 to the power 1, but we kind of ignored that because this equals to 0 anyway, so we don't have to focus on that. So that's why this example I cheat. One of the most important thing is they are not different numbers. They all represent the same number. It just depends on which notation we are using. For example, we are using notation base 8 over here. Over here we're using base 10, base 16, base 4, base 2. And over here there's also bases like 5 and 3, which literally nobody uses, or I have absolutely never seen anyone use that. So you don't have to worry about that. The ones you should be worrying about is this. Yeah, that's a mess. But anyway, remember, do not confuse the representation with the numbers. And in the piazza we have seen questions like how to change to one to another, or if changing from one to another changes the number or something like that, which now you know that it doesn't matter, because like if you use something like this, it's going to be used as integer. If you use something like this, it's going to be uint, and so on. So as you can see, the numbers are the same, but it depends on how you are representing them. Like in print statement, if you use %p, it just prints the hex, but it's still the same number. So I hope that makes sense. And remember the hex, or the 16, that one is mostly used to make binary understandable, because binary is basically 0 1 0 1 0 0 0, something like that. And if you had to look at this and understand what it means right away, it would be hard to work with. So that's why we have something like if. So with if, we know that this number is going to be 15 or something like that. So that's why hexadecimals are used, and sometimes even octa are used, but like not as much. But yeah, so here is a conversion of like a number, which is this, and how to convert it to base of 2. So one thing that I usually do to convert the numbers to base, I keep dividing them as it's shown over here. So what we can do is something like this, divided by 2, and we have 3, 6, 9, 5, 0, and a remainder of 1. And we keep going and we keep dividing it by 2 again and again. And if we keep going like this, we will come somewhere where we have something like this, 0, and we divide it by 2, we get 1, 0 divided by, and then we just go back up, and that's our binary representation. You probably don't have to do this math in your exam, but that's just one way you do it. So I just wanted to show it to you. And to convert from binary to to decimal, we just use this. So over here is going to be 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and so on. And if there's a 0, you can just skip it. So we are completely skipping it over here. We sum them up and we have the exact same number that we converted from before. The same can be done with hexadecimal as well. In that case, instead of dividing by 2, you're going to divide it by 16. So if it's something like this, you divide it by 16 and you get 4, 6, 1, 8, and the remainder is 13, which is equivalent to D. You divide it by 16 again, you get 2, 8, 8, and 10, which is A. If you keep going like that, you get something like this. Again, you go from the bottom to the top. And one another thing to understand is, instead of just like stopping at like 0, 1, 2, 9, and then we have like 10 in 10 base, but like over here we are using A. For 11 we use B, for 12 we use C, for 13 we use D, for 14 we use E, and for 15 we use F. 16 is going to start at the beginning, so it's going to be something like 1. Okay, I kind of forgot. Oh, it's going to be this. This is equal to 16. Sorry, I kind of forgot. So yeah, there's another easy way to convert like hexadecimal. Over here we did divided by 16. If we have the binary number, we can just divide them into 4 digits and then convert them to hex. It also works. And honestly, I'm just going to leave it to you to realize why that works. If you can figure it out, good. If you cannot, I am more than happy to show it to you. And you can also do the same with octal as well, but in this case you divide them into digits of 3 and then you convert them. Why do you think over here we are using digit of 4, but over here we are using digit of 3? Try to figure that out. It's pretty easy, honestly. So yeah, so over here you have the basics of how you are going to count the bases. For example, it starts in base 2, it's 0 and 1. In base 8, it stops at 7. In base 10, it stops at 9. In base 16, it stops at 15. So it's usually n minus 1, right? Where n is equal to the base. So that's it for this video.